What's up, math fans? I want to talk about function values of special angles. And when I say special angles, I mean angles that are found in special triangles. These are the two of the more special triangles. There is an isosceles up here and an equilateral down here. We'll talk about what that means in a second. You're also wondering what function values are. Well, hopefully you've already seen the intro to trigonometry video. And function values are basically the sine, the cosine, and the tangent of a given angle. So if you forgot those formulas, they're right here for you. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. All right, so I'm using three different formulas to find three different function values of three different angles. So where do we find these angles? Let's start with the isosceles. What do you know about an isosceles triangle? Two legs are the same measure, and then you have your hypotenuse. Also, if two legs are the same measure, two angles, the two acute angles are also the same measure, they have to be 45. All right, 45 degrees plus 45 degrees is 90 degrees, and then the right angle is also 90, 90 plus 90, 180. Every triangle has a sum, has the three angles sum up to 180. So there's your isosceles triangle. Now the lengths can be different, meaning you could have a leg of 5, and then the other leg would also have to be 5. The legs have to be the same. When I said the lengths are different, meaning my favorite size, maybe I would choose 7, and then that one would have to be 7. Maybe your favorite number is 10, so you would also put 10 there. So that's what I mean by the size of the isosceles triangle can shrink or grow. It could dilate. I'm going to actually put x. This is going to represent everyone's favorite number. And of course, if this is x, that has to also be x. And we are going to attempt to find the hypotenuse using what? The Pythagorean Theorem. What is that Pythagorean Theorem? I'll do it down here. A squared plus b squared equals c squared. Now I'll do it quickly within a specific number, but I'm trying to develop a formula, so then I'll have to do it in general with x's. So let's say you picked, oh, my favorite number is 5. My leg is 5, my other leg is also 5. Let's find the hypotenuse. Okay, fine. 5 squared plus the other 5 squared is equal to c squared. 25, 5 times 5 is 25, plus another 25, that's 50, equals c squared. If your variable is squared, the inverse is to take the square root of both sides, because a square and a square root will cancel out, leaving you with the variable alone, and then you just tell me what the square root of 50 is. Don't run to the calculator. This video is actually to help you do high quality math without a calculator. So square root of 50, yes, you might get a decimal, I don't know, what is it, 7.01 or something, but in trigonometry, we rather have answers in exact values, simplest radical form, because if you go to the calculator, you're going to end up rounding. We don't want that. We want an exact value. So I'm going to factor the 50 as a radical 25 times a radical 2. You could also factor 50 as 10 times 5, but that's not helpful because I need a perfect square here. So the square root of 25 is 5, and then I don't know what the square root of 2 is, so I leave it. And there would be your third side in a specific example. I need a general example. So I'm going to go back and use x. That way I'm going to develop a formula. So I have x squared plus x squared equals c squared. All right? A squared plus b squared equals c squared. X squared plus x squared, those are like terms. There's two of them, so that's 2x squared equals c squared. I need c alone, so I'm going to take the square root of both sides, and that will cancel. What happens here is I'm going to actually factor or rip that apart and rewrite it as the square root of 2 times the square root of x squared equals, now c is alone. Well, I don't know what the square root of 2 is, but I do know what the square root of x squared is. It's x. So c equals x radical 2. I'm going to go over here, put my x radical 2. If we were doing a specific example and there was a 5 and a 5, it would be 5 radical 2. If your favorite number was 9 and you put a 9 and a 9 and did the Pythagorean Theorem, you would get 9 radical 2. So this represents the general case for no matter what your favorite number is. Now, my goal for this video is to find the three functions, the sine, cosine, and tangent of these angles. So let's look at the picture and tell me what is the sine of 45 degrees. But wait a minute. There's two different 45 degrees, so it doesn't matter. Pick your favorite one. I'm used to the base angle, so I'm going to use the base angle of 45 degrees and label my three sides. We knew this was hypotenuse. Opposite is across or opposite the 45 degree angle. And here is next to the 45 degree angle, that's my adjacent. So the sine of 45 is opposite over hypotenuse, so that's x over x radical 2. That's it. Cosine 45, adjacent over hypotenuse, and of course you get the same answer because it's isosceles. However, tangent is opposite over adjacent, that's x over x. And I'm done. So these three answers are going to go on my table. I just want to organize my thoughts, that's why I made a table. But you also learn in math that you should have simplest form, so I'm actually going to go over here and simplify. X over x is going to cancel out, leaving you with radical 2. But the radical 2 is on the bottom. There's actually a 1 on top, so it leaves you with 1 over radical 2. Same thing. Cancel, 1 over radical 2. Similar thing, x over x, your favorite number divided by itself, is 1. So it's actually these three values that go in the table, right? Still no, because you should have learned somewhere in your math or algebra 2 career that this is an irrational number. And an irrational number in a denominator of a fraction makes the whole thing irrational. So we're going to do something called rationalize. In order to rationalize, we're going to multiply the fraction by anything we want as long as we do the same to the top and the bottom. So basically that's called multiplying by 1, and that doesn't change the value. You're allowed to do this. So the version of 1 that I want to use is that number. So radical 2 over itself. Why is this perfect for me? Because radical 2 times radical 2 is radical 4. And the square root of 4 is a perfect square. It's 2. 1 times radical 2, I don't know what that is, I'm going to just leave it as radical 2. So there is my simplest rationalized version. This is going to go in the table. Guess what? The same thing happens over here. Radical 2 over radical 2 gives me 1 radical 2 on top. Don't write the 1, that's for rookies. Radical 2 times radical 2 is radical 4, square root of 4 is 2. So there's my cosine, and oh, I don't have to fix that, that's already 1. So we got radical 2 over 2, radical 2 over 2, and 1. Try your best to memorize those values. They make calculations so much faster in the future when you're solving for unknowns. What's the height of the tree? What's the distance across the river? Stuff like that. Let's do the same question, but for 60 degrees. For me to use trigonometry, I need a right triangle. So there's a trick here. I'm going to take a perpendicular line. Boom. Now, early in the video, I called this thing an equilateral. If it's an equilateral triangle, 60, 60, 60. All angles are 60. This point here, I'll call it C. Now that I've cut it in half, I'm going to redraw it. Call the top A. This is still B, and C is the right angle. Notice B is still 60 from over there, but A got cut in half, so this is only 30. So now I can ask you a bunch of different questions. I can ask you for the sine 30, the cosine 30, and the tangent of 30. The thing is, I need numbers. So I'm going to go over here, and I'm going to label this entire base 2x. And if the entire base is 2x, all three sides, because it's equilateral, equal 2x. So this is 2x, and that's 2x. When I cut out my picture, A to B is still 2x. B to C, not 2x anymore. It's half of that, which is only 1x. And I have no idea what A to C is, so you're going to have to use the Pythagorean Theorem to figure it out. All right? Let's see if we can do that quickly. So that's going to be A squared plus B squared equals C squared. So that's x squared plus I don't know squared equals 2x squared. That's x squared plus I don't know squared equals 2x times itself is 4x squared. I'm going to isolate the b squared by subtracting x squared on both sides. This gives me 3x squared, still not done. Square root, and b equals x radical 3, because I split up the 3 and the x squared, and this is a perfect square, but this is not. So now I'm going to go here and put x radical 3 on the third side. Then we're going to do what we did with the isosceles. Label it, for 30, so if 30 is up here, label it opposite, adjacent, hypotenuse. What are you going to get? Sine 30 is going to be x over x radical 3. Cosine 30 is going to be x radical 3. Oh, that was wrong. Ooh, good catch. Going to be x over 2x. Cosine is going to be x radical 3 over 2x. And tangent is going to be x over x radical 3. Okay? Now, on your own, I'm going to ask you to do the same thing for sine, cosine, and tangent of 60. And you have to simplify these three fractions. And in part 2, I'll put up the rest of the answers. All right? Thanks for watching. See ya.